Well, good morning, everyone. My name's Emil Olbrich, and I just want to welcome you to this morning's session with Joey Villamil from EXFO. He's the market development manager there. We're also going to be hearing from Mark Watts, who's an associate fellow, knows a lot about ORAN at Verizon. I also want to thank RCR Wireless for giving us this opportunity to talk about infrastructure, to talk about what's happening with regards to the backhaul and the networks. And then also want to thank Kelly Hill, our host, for putting this on every year. I think this is the third time we've had the opportunity to do that. So I really appreciate that. Anyway, I'm going to turn it over to you, Joey. Take us in.
Thank you, Emil, and good morning to everybody. As Emil mentioned, my name is Joey Villamil, and we'll be discussing the promise of 5G. I mean, it's been quite some time since 5G was launched. So if we can show my slides, we can get started. All right, so 5G, like as I mentioned, was launched probably in 2018, 2019. So it's been quite some time since 5G was launched. And what was the promises? There was a lot of things. I mean, things as crazy as remote surgeries, as something as simple as, lower latency and things of that nature. So have we achieved those promises? And unfortunately, in a lot of instances, a lot of people probably will say no. And the reason being is because we have a lot of underserved or unhappily served people. There's about 2.1 billion people globally that fall into that category, and probably about 53 million people in the U.S. that fall under that category. That could mean anything from zero service to just being served by one company that might not even offer high speed in those areas. So and as a result of that, the monetization for the carriers probably is nowhere in the area where they will want it to be. And some of that is because the main service that is being offered right now is mainly wireless service, devices, people making phone calls, sending texts, and streaming. That might not be exactly what where the money will be for the carriers to recuperate some of their investment. So some of the things that we might see will be fixed wireless access, and that could be something as simple as a point of sale, where you're on a food truck and you give your credit card and they process that transaction. Imagine if that goes down, a line of people waiting for their food. I mean, I don't know about anybody else here, but if you get between me and my food, it's gonna be something. So things like that, and then something as serious as people being provided with a wireless service in their homes for kids to do their homeworks and work. So that's why it's quite imperative for us to kind of get to this point where we'll be able to offer better services, and from the carrier's perspective, they will be able to improve the return on investments from all the spectrum and equipment that they purchase and they were able to deploy for us. So as I mentioned, the main takeaway from this is that there will be new services and new things that the carriers will offer in order to improve the services for people, which is a big benefit for the community, but it's also important for them so they can improve the return on investment. Next, please. So how did this transformation started? Originally, if you're familiar with wireless, people were deploying cell sites, and we have continued to deploy cell sites, and from larger cell sites, to provide macro coverage to more centralized or focused coverage like small cells, or even in building solutions like that. There were quite a few cell sites built in a lot of different locations. But when you deploy the cell sites, there's a second part of this that needs to be included, and that is the upgrade to the transport network. If you just deploy cell sites and you don't improve the transport network, you're going to end in a situation where even though people might have service, they might not have the level of service that they're expecting. They might not be able to perform the promises that were given to them. They might not be able to do their jobs, or they might not be able to do homework, something as simple as that. So upgrading those networks and transport networks it's quite important, where a lot of the times people focus mainly in the cell site building aspect of it. So it's important, and we've seen some carriers that have performed some upgrades from 10 gig to 100 gig to even 400 gig right now. So we'll discuss that more in later on during our conversation in the process. Next slide, please. So there's a few things here. So there's we perform a survey, a global survey with a lot of different carriers, and they kind of were telling us what was the most impacting issues that they see. So from here, 1 through 4 here, what you see is the obvious problems. Fiber issues, obviously, if you have a break in fiber, that's obviously going to bring a cell site down. That's a transport problem. When you're commissioning the site, you might have SFP issues, and if you don't take care of them during commissioning, they might surface after the site's on air performing service. Same with radio issues, from power outages to defective radios, to configuration issues, where you might be able to launch the site, but the configuration is incorrect and you might have issues. Same thing with backhaul issues, reliability, routers going down. So those are type of problems that are fairly common. Next, please. Advance. So the next type of problems might not be as service impacting, if you will, but they are something like PIM issues, passive intermodulation. Uh, it could be external, it could be internal to the cell site, but those are the type of problems that over time will degrade the service of the customers. Advance, please. The obvious RF interference. This is as old as cellular networks have been in existence. People get from the need of not having service, a lot of people might try to enhance their own coverage without realizing that they're causing interference to their neighbors and the community at large, from people that might be worried about who's looking into them or what they're doing. So they might have blockers out there, or even people might not want cellular service in certain locations because they want people's attention. So interference is a pervasive problem that we have to continue to fight. Sometimes it's malicious, sometimes it's inadvertent, sometimes it's just out of ignorance. Advance, please. And the last one is timing issues. With the advent of TDD, bringing out C-band, standalone networks, configuration issues, there's you will also have problems. So the difference between the top part and the bottom part is that the top part is high impact. You will see it right away. It will get a ticket issued immediately. People will get dispatched. They will try to solve that problem immediately. The bottom part is a degradation issue, and sometimes you will still have service. You might have coverage, but you're affecting people, and sometimes people might not even communicate that they're being affected. They just continue to chug along and until they get tired. And sometimes they might change carriers hoping that their situation improve, but this is problems that will continue to be pervasive and get growing and growing until it become unsustainable. And then the carriers realize that they have a problem in the issue, and that's things that you need to be on the lookout for. Next, please. So this is just a quick slide showing some of the interference issues, how when you have PIM, when the site gets launched and without PIM, how the level of coverage looks to the customer, where they enjoy coverage as PIM issues surface, or whether it's because they're introduced after the site is being launched, or because they were already there from day one. People might think when they go and purchase a service from a carrier, they might think that they have coverage in their home. The coverage shows that it's supposed to be there, but when they get to their home, because of the interference that is created, people are not able to enjoy their coverage. So the coverage essentially shrinks because the noise floor increases, and when the noise floor increases, the coverage gets pulled back. And just from a small problem being introduced into the network, you can see that you can potentially lose 3/4 of the service in an area. So even pretty sneaky, because it didn't show on the top part of the problem issues that the carriers were thinking were high impact versus low impact or degradation, but it's a really big problem, and it will interfere with the carriers receiving the return on investment of the spectrum that they purchase when there is things out there that is causing problems. Advance, please. Same type of issues. Pretty sneaky. Carriers purchase the C-band, introduce it with TDD, and is there interference there? It's essentially TDD. What it's doing is separating the communication by time, so a small space of time, and it's transmitting on the essentially on adjacent frequencies, and sometimes in the same frequency on each specific carrier. Each carrier has their own frequencies, and they are reusing them. What this is causing is something that is commonly known as ducting, where from a distance, because you're using the same frequency, it might interfere on themselves, and now the communication gets broken, and again, you're not enjoying the level of coverage that you were expecting for simple things like fixed wireless access, private networks. A lot of different things get affected by this, and while again the difference in one type of problem versus the other, it might affect the investment of the carriers and also the enjoyment and use of the service for the customers. Advance, please. Oh, this is just a quick animation, so advance, please. And as mentioned, that's a great problem. Another survey that we perform with carriers globally, it's that a lot of what's eating on their budgets, on their operating expenses, essentially is multiple truck rolls. And why are people having to go to site in multiple instances? As the incredulous friend there shows with the picture, the installation of the cell site might have been a problem. There might be RF problems where you're talking about interference, PIM, timing, things of that nature. It could be a fiber problem, something as simple as the fiber not being inspected when it was installed. When we speak about transport, essentially what we're talking about is fiber being deployed to the cell site. And if that fiber is not installed properly with care, as delicate as it is, there might be a problem later on. Same thing with the equipment. Equipment needs to be installed properly. What are the things that, it could be antenna issues, it could be equipment, baseband, remote radio heads. It could be a lot of different things that is causing the problems that causes the multiple dispatch to the site. And again, what this is doing is when you're redeploying people, you have to pay them. And even if site is under warranty and you're not paying them, the cell site is down what they're troubleshooting. So this might delay the return on investment for the customers. People might churn just because they were told that they were going to have service in a specific location. And when it comes down to it, there's a silent problem that is continually degrading the site, or it could be from day one. So with that, please advance. And just some of the things that you may want to do to make sure that you ensure and maximize your return on investment. And I think that we're kind of close, but these are some of the products that you can reach out later after, and we can discuss further for us to kind of address a lot of the different issues that you might encounter when installing sites, maintaining them, troubleshooting, whether it's the fiber at the cell site, fiber on the transport connectivity, or different areas. Next, please. And thank you. And I'll hand it back to Emil.
So I have something funny to tell you. So I went offline for a little bit. My backhaul went out. I got a notification. I got a text. See my Wi-Fi go out. I'm like, oh no, I'm right in the middle of a meeting. So it's kind of ironic that we're talking about this and about resiliency right now.
please give your carrier an opportunity to correct the issue and don't just churn.
Acting on a hot spot right now, so I thought that was appropriate. I did not plan that. So anyway, I want to start off with one thing that is a big deal with regards to 5G, just in general. Mark, I'm going to give you the floor here initially, and then Joey, have you follow up. Money is the big thing. How do we make money on 5G? How do you monetize it? And one of the biggest issues is reducing operational expenditures. And operators don't like doing multiple truck rolls up to a site. So when you are either deploying a new site or putting a new site in, what do you look at as a way to be able to monetize that and reduce the number of truck rolls going out to a site when you're putting in a new 5G site?
Okay, great. Thanks. My name is Mark Watts. I'm with Verizon, and my focus is on front haul, mid haul, backhaul, and also O-RAN alliance activities. So I think those are two distinct questions. One, monetization, and it's taking some time, but seeing quite a bit of activity not only in Verizon but from what I see from other carriers in the IoT space, private networks, and emerging slices, of various types. Verizon just formally announced a public safety slice and a previously deployed slice for advanced meeting and video features. Those are just a couple of examples of monetization. EMBB, which was, I guess you could probably call fixed wireless access in this context. And rolled into slicing could be even future ultra reliable or low latency type of services. So there are things. It's not for every consumer. I think that's where the misconception kind of creeps in, is that a consumer doing Facebook posts and whatnot don't really see any changes, but they're that's the general consumer, but there are specialty advances in 5G of those things that I mentioned before. As it relates to truck rolls and fast fixes and things of that sort, we're looking at a few things. One being leveraging the data that can be trained to anticipate failures, whether it's SAP failures or other types of failures, and also unraveling and unleashing what is called fiber sensing, which is an interesting technology to also anticipate failures that may allow for fewer truck rolls. So there are some advances in fiber technology and using say AI training models to anticipate failures. So there's a couple of things that come to mind.
Yeah. Joey, we did get a question from the audience, and maybe you can help clarify it. They asked why CPRI analyzers needed to find PIM.
So there's a couple of ways to finding PIM. So one of them is the traditional route where essentially you generate you connect equipment to the cell site while the cell site is offline, and you introduce through test equipment the signal, if you will, to kind of verify that there's no PIM. And normally that method is used at the early stages of the site being built. Once the site's on air and traffic is going through it, if you do it in that traditional way, that will be a disruption on the cell site. With the CPRI method, what you will be doing essentially is that you will be tapping into the fiber of the cell site, and what CPRI refers to is the way that the baseband unit communicates to the radio head. And what we're doing is we're doing is we're just looking through it while the cell site is still on air. And that what that will do is that, one, it will allow you to detect if the site have PIM, but the people that are enjoying service in that location will not have a complete interruption. The people that didn't have service because the PIM was there to begin with, still probably will have the problem, but while we're solving the problem, you don't need to bring the cell site down. So that's why it's the benefit, if you will, of doing it with the CPRI method.
So question, I guess, just building up that, if you look at traditional Ethernet backhaul, and the way we've used it in 4G, for a decade now, right? And you look at 5G networks and 5G advanced networks, we're getting more and more bands put in, more SA networks. So there's a big necessity for having advanced, MPLS or some type of network. Does traditional Ethernet backhaul, do you see that meeting the needs? And if you look at the SLA demands for current networks and 5G advanced and going into 6G, if we dare talk about that for 100G and 400G networks, do you think that we're where we need to be right now? And I'll let you take it off, Joey, and then Mark, you can give it from the carrier perspective.
And Mark probably will expand on this. For the most part, when 5G was initially launched, probably the answer was no. There was not enough transport bandwidth for the services that were being built, and but the carriers and everybody that was working there figure out that they needed to expand that, and they went from 1 gig to 10 gig. And now, if we're really gonna fulfill all the promises, now we need to start getting to 100 gig, 400 gig. So to answer your question, probably in some areas, yes, there's enough bandwidth right now. In some areas, probably there's not enough bandwidth right now. And the SLAs will have to kind of, if you're talking about between the carriers and the customers, where they agree to certain level of service, most likely in a lot of areas, yes, is being hit. But if you're gonna really get to the next level and improve coverage and hits on some of the areas that Mark spoke about, the 5G advancements, you probably going to have to continue to increase the transport networks, and internally for the carriers, they'll need to monitor them and use some of the AI components that Mark mentioned.
Yeah, so two things. So pre 5G, the typical front haul was, CPRI. Now, eCPRI is becoming more of the norm, and that provides, the flexibility that is very useful as we increase, the amount of, spectrum that, carriers can utilize. Spectrum is the ultimate driver. So as the demand curve continues to grow, like, upward, more spectrum is needed. Therefore, more front haul is needed. But fortunately, eCPRI allows for, a slightly reduced, front haul demand. The other part is the flexibility of the, the services I mentioned before, is that, the steerability, which could be driven from a SRv6 kind of point of view in the mid-haul space, allows for traffic to be custom as far as what the endpoints are, and where the 5G, core happens to sit relative to the radio. So flexibility is one thing, and then steerability is really, the second thing that really helps us manage 5G traffic.
So let me ask you about that. Where do you see either being SRv6 or segment routing or both, or what does that look like for you guys specifically? And then maybe going into the future, does it matter?
Yeah, I think, SR would be more of a generic term. It could be, MPLS based or, IP based. But no, the steerability and the source-based routing techniques can be very useful, especially as newer services that haven't even been launched yet could benefit from its steerability.
So, and you mentioned eCPRI, so we'll just launch right into the, kind of this. You guys have done CRAN for a long time. You're doing Open RAN now. I mean, Samsung's the largest Open RAN vendor, and so looking at that, has that changed how you are architecting transport networks and what you see? And I'll let you guys both answer that as you look at your networks now as you deploy Open RAN. Is it changing your thought process and how you deploy those?
Yeah, yeah, it does. It allows for that, say front haul device, if there is one, to be multi-purpose, right? So for a carrier like Verizon, which has both a wireline space and a wireless space, there's opportunities to, share resources. Going back to one of your first points there, Emil, is the expense and capital, pressures. Shareability of devices plays perfectly hand in glove in that particular context.
Yeah, for us, essentially, eCPRI or versus CPRI, what allow us to do is what we're able to help with in those areas is that we're able to test them, make sure that right before the site gets launched in the front haul, that everything's talking to each other and it's the right connectivity. Again, to help the carriers reduce truck roll, reduce the time that it takes their technicians and their contractors install the network. So we're there hand in hand supporting both the carriers and the people building the new sites.
Yes, it looks like we're out of time. I'm getting the hook right now to end this. But I'm assuming, and I think the irony is, my backhaul went out, so I need resilient backhaul on my end, quite frankly. So I won't name who the carrier was, but I'm assuming both of you can be found on the internet, LinkedIn, I think also here on the forum. Is it okay if people reach out to you guys if they have questions afterwards?
Please.
Certainly.
All right. Thank you, everyone. I appreciate it.
Thanks.
Thank you.